This example is asking us to find the original function f of x if we already know what its first derivative is. The way we do that is using something called an integral or an antiderivative. So before we actually look at this example, I'm going to start off by showing you a function and its three derivatives. We need to be able to find patterns of how to go from one term in a derivative back up a step. And we need to find a pattern that's consistent no matter what we do. So something that we should look at the exponents as we move up a level. Look at the coefficients as we move up a level. And the pattern for this can be shown here. On the left side it says if we have a first derivative in the form of x raised to an exponent. This is how we go up a level to find the original function. It shows that our exponent has 1 being added on, and our coefficient, which in the original is actually 1, we're dividing by that new exponent. So in other words, if I go back to this other example, let's look at the 6x to the 5th. To go up a level, 1 is being added on to the exponent, so 5 plus 1 is 6, and then my coefficient in the derivative is being divided by this new exponent. So it's actually 6 divided by 6, which gives me a 1. Now the notation on the right is the typical notation that we will start to be using. The dx is not any kind of calculation, it just goes along with this symbol. But finding the integral or antiderivative is the same. So I'm going to go through just a couple examples to demonstrate this. So this was the original that was shown. So if I want to go back and find my original f of x function, I'm going to start with my first term, and I'm going to start with the x cubed. The first thing I need to do, according to the format, since I have x to the third power, I need to add 1 onto that so it becomes x to the fourth. The next thing I need to do is take the coefficient, which is 20, and divide it by that new exponent of 4. That means my new coefficient will be a positive 5. And I'm going to repeat that. So for my next term, I'm going to start with the x, so it becomes x to the third. I add 1 on to the 2. Next I need to take this coefficient divided by the new exponent. So that's a positive 2. My third term would be x squared. Then I take the coefficient of negative 2 divided by my new exponent of 2, and that's just a negative 1. And I'm just going to show that with a subtract sign. And my last term, an x is not shown, but it does mean x to the 0 power. So if I add 1 on to that, I get x to the first. And then when I take that coefficient of 7 divided by 1, which is my new exponent, that's just plus 7. But the last thing I need to do is show plus c. Because if this were my original function, I could have any numerical value down here for my constant. When I derive it, that constant no longer exists, so I do need to show plus c. Okay, my next example, same thing. So if I'm going backwards to look for f of x, I'm going to start with my first term. Its new exponent should be a 5. Then I would take my coefficient of 5 divided by that new exponent of 5, and that would just be a 1. Second term, my new exponent's 4. Then I'm going to take this negative 8 divided by that 4, which is negative 2. My third term would be x cubed, and I would take that 7 divided by 3, so I just will leave that as a fraction, 7/3. And then my fourth term, keep in mind that's x to the 0, so now it's x to the first, negative 8 divided by 1 is just negative 8, followed by a plus c. Okay, this example is just to demonstrate these are two different ways of looking for an antiderivative or integral. You can see both notations. So I'm going to start to go to this notation so you get used to that. And like I said, d of x is nothing more than just part of the notation. It's nothing that we need to try to find an antiderivative for. So if I were trying to integrate this, my first term, my new exponent is 3. 3 divided by 3 means that would be a 1. Middle term, that will become x squared. Then negative 4 divided by 2 is negative 2. My third term would have a single x, x to the first, and then 2 divided by that 1 is just still a positive 2. And then last I need my plus c. Okay, when I go to integrate this one, first thing I do is add my 1 onto my exponent, which I get 5. My coefficient, which was originally a 1, gets divided by that 5, so I'm just going to leave that as the fraction 1/5. My next coefficient would be 2 divided by the 4. That reduces to be 1/2. In my third term, I originally had a coefficient of 1. I'm going to divide it by that 3, so that's a positive 1/3. My next term would be negative 4 divided by 2, which is a negative 2, so that's my new coefficient. And at the very end, I need to include my plus c. Try out these two examples. When you're finished with it, you can continue on with the video. I would just pause. Once you hit play again, then you can see the answers.